These last four examples are meant to remind you of the fact that we often need to rewrite things, same as we did for derivatives, before we can take antiderivatives. So when we have the antiderivative of x plus 2 times x minus 1, you don't have anything that looks like a product rule yet, so we're actually going to need to multiply that out. So this is the same thing as the antiderivative of x squared plus x minus 2 dx. If you're not sure where that polynomial comes from, go ahead and multiply out x plus 2 times x minus 1, combine like terms, and you should end up with exactly this expression here. Then the antiderivative is going to be x to the third over 3 plus x squared over 2 minus 2x plus c, which we could also write as 1/3 x to the third plus 1/2 x squared minus 2x plus c. In our second antiderivative that we have here, the antiderivative of the quantity 2x squared, we're going to need to get rid of those parentheses before we can do anything. We don't have anything that looks like a chain rule equivalent. So this is the same thing as the antiderivative of 4x squared dx, which will be 4 times x to the third over 3 plus c, or 4/3 x cubed plus c. Don't forget when you have things in parentheses and they include constants to make sure that you're squaring everything, including the constant inside, before you try to apply either derivative or antiderivative rules. Our third example just simply requires converting a radical expression into rational exponent notation. So we can think of this as the antiderivative of x to the 3/4 power dx. If we increase that exponent by 1, we'll end up with x to the 7/4. We're going to divide that by 7/4. That is, of course, plus c. And we'll end up with 4/7 x to the 7/4 plus c when we do that. In the final example that you see here, we have a rational expression with a monomial in the bottom, which means we can divide it into each of the terms in the top. So we could also think of this as the antiderivative of 1 over, well, let me write it this way, x to the negative 2 minus 4x to the negative 4 dx. So you can either think of this as taking x to the 4 and dividing it into x squared, also dividing it into negative 4, or you can think of bringing it up to the top as x to the negative 4 and multiplying it by both of the terms in the top. Either way, we'll end up with this expression, and these are powers that we can work with. So our antiderivative will look like x to the negative 1 over negative 1 minus 4 times x to the negative 3 over negative 3, and we're going to have a plus c on there, and I'm running out of room here a little bit. Oops. Let's get back to our bamboo here. So we will have negative x to the negative 1 plus 4/3 x to the negative 3 plus c. We could, of course, put that back over a common denominator and rewrite it back into a quotient type of expression. And if you need to, you should be able to do that. But for right now, in terms of just taking an antiderivative, this is what we're looking for. Take its derivative, do a little bit of algebra. You should, of course, end up back where you started.